Hi everyone, my name is Mariam Alaverdian, and today I will be presenting to my research conducted over this summer at MIT. I was supervised by Dr. Robert Point, and we compared two methods to see which one is the most efficient one when finding the log optimal portfolio. But before I jump into the research itself, I wanted to give a brief and simple overview of what optimization is. So optimization is the maximizing or minimizing an objective function relative to some given constraints. The objective function is the output that we are trying to optimize, and that output has inputs. Those inputs are called variables, and they can be controlled with constraints. Constraints are equations that limit how big or how small our variables can get and show any relation between those variables. From there, we get feasible solutions, and from feasible solutions, our goal is to find the optimal solution. And now, without further ado, let me introduce you to my research. So the goal of any financial portfolio is to maximize the return, minimize the risk. A way to achieve that is by finding the optimal proportion of each asset within the portfolio by solving an optimization problem. In our case, the objective function is going to be a logarithmic function, and our goal is to find an optimal solution for this problem in the most efficient manner. So we will be looking at two different methods. The first one is called Frank-Wolfe Method, and the second one is a method introduced by Dr. Thomas Carver in one of his papers that I will be referring to as Carver's method. The reason why we care is because a logarithmic objective function, that is a nonlinear optimization problem, and that can take excessive time to solve, especially when we have a larger data set. We want to find the algorithm that is the most efficient one. So here's the objective function. If you want more details about the objective function or the variables, please feel free to refer to my poster. But as you can see, it is a logarithmic function. And the only constraints that we have are that all of the proportions of the assets should be non-negative, and they have to sum up to 1. So what Frank-Wolfe's method does, it considers the local linear approximation of the nonlinear objective function, and with each iteration, it moves closer to the minimizer of the linear function. With Carver's method, it finds a log optimal portfolio by maximizing the expected log return over the simplex of the proportions of the asset that are non-negative and sum up to 1. And what's really interesting about Carver's method is that every new iteration is defined as a multiple of the previous iteration. And what I mean by that is every new iteration is equal to the step size times the previous iteration. For the methodology, I coded 4 algorithms on R. The first one was Frank-Wolfe with binary search line search on the step size. The second one is Frank-Wolfe without the binary search line search. And third one is Carver with binary search line search. And the fourth one is Carver without binary search line search. For the data set, we had a portfolio with 53 assets. To be more specific, there were 52 stocks, and then the 53rd asset was US dollars. And we looked at 100 time periods. To compare the algorithms, we looked at the number of iterations and time in seconds it took the algorithm to find an optimal solution. And we looked at the number of iterations and the time for different optimality gaps. So here's one of the results for a tolerance level of 10 to minus 6. As you can see, Frank-Wolfe with binary search line search returned an optimal solution after 3 iterations. Frank-Wolfe without the binary search line search returned the optimal solution after 11 iterations. In both cases, we got the results within less than a second. For the Carver's method, however, for both of the variations, it took more than 15,000 iterations and more than 350 seconds to return a result. And we applied the same process for different optimality gaps and tolerance levels. And in all the instances, Frank-Wolfe proved to be more efficient than Carver's method. So we conclude that for this kind of problem, for a logarithmic log optimal portfolio problem, Frank-Wolfe is the more efficient algorithm to use. Some future work to consider is comparison to the performance of other algorithms that are for nonlinear objective functions, and Frank-Wolfe with an expensive gradient estimate. And that is it for my lightning talk today. Thank you very much for listening. And I'd like to thank Rob, Zikai, and Rainey, as well as the entire MSRP staff for making this research possible and supporting me and guiding me through this process. And that's it for today. If you have any questions, feel free to email me. My email address is on your screen. And have a great day. Bye.